On October 15, 2010, Con Edison and the FDNY conducted a live suppression test at the Fresh Kills 345,000 volt substation. The purpose of the test was to measure leakage current from the high voltage conductors back through the suppression agent to the fire department apparatus. Hello, my name is Anthony Natali, and I'm with Substation Operations Emergency Response Group. Before we get to the results, here's a brief history on the project. In 2006, we began a joint venture with the FDNY to prove that water could be safely used in a high voltage environment to extinguish or protect equipment impinged by fire. Two recent incidents caused us to rethink our response posture. We realized that we needed to look for a product that will allow us to knock the fire down quickly without compromising the safety of first responders. Along with the FDNY, we looked at the products available on the market and chose three: AFFF, alcohol-resistant foam, and F500 encapsulating agent. Preliminary testing was conducted at the Fire Academy using a disconnect switch energized to 50,000 volts. The current leakage values from the AFFF and alcohol-resistant foam exceeded the established safety limit of 0.9 milliamps, but the F500 agent produced leakage values similar to that of water, which we already knew to be safe. F500 does not fall into the category of traditional foam. It is considered an encapsulating agent capable of providing quick knockdown coupled with heat dissipation. These promising test results enabled us to move forward and conduct a live field test at the Fresh Kills substation. The selection of this site was driven by our need to conduct the testing on the highest voltage that the fire department could reasonably encounter.
For the Con Edison fire suppression test, the FDNY provided 2 pumpers and a tower ladder. Hello, my name is Battalion Chief Steven Sanfilippo. All 3 were used to apply F500 fire suppression agent to the live bus at Con Ed's high voltage station in Staten Island. All our equipment was grounded before any testing commenced. 1 pumper was on a hydrant taking in water and also supplied water to an additional pumper which had F500 concentrate in their booster tank. We mixed it to a proportionate and then used the 3 means of delivery. We used a fixed mounted multiversal nozzle at ground level, a deck gun, and a tower ladder. The nozzles were wired up to measure any residual voltage at these various distances and spray patterns.
For this test, it was my task to come up with the circuitry and equipment. With the field technicians, we connected up the equipment so that we could determine which distances was safe to spray the F500 concentrate and water mixture on live bus. My name is Tim Sieben, and I'm a technical manager for protective systems testing here at Con Edison's substation department. What we ended up doing was we set up a portable van at the substation, regrounded it, and then stretched wire to the nozzles. We also installed the safety gap, which is very important in limiting any voltage coming back to the equipment, preventing any damage or potential safety hazards. The wire that was connected to the nozzles was run back to a 5,000 ohm resistor, which simulates someone holding that nozzle. We were able to measure current coming back from the F500 concentrate and water mixture. It was measured by a digital ammeter and 2 analog meters. A digital fault recorder was also installed to record the electrical waveforms, so later on we could go back and look at the exact data on a computer.
The testing philosophy required us to look at a variety of ways the foam could be delivered by the fire department in order to prove each method safe. The safety target for leakage current is 0.9 milliamps or below. 0.9 milliamps is the level at which leakage would cause a physiological effect, basically an electrical shock as we know it. In the first test, we used a fog pattern. F500 was delivered from a fog nozzle at a 30-degree pattern onto the 345,000 volt overhead conductors from a test stand. Leakage current back to the delivery nozzle was measured and recorded by our technicians during the test. We began the test at the 25-foot standoff distance from the conductors, and the readings varied from 80 to 90 microamps. We continued to move the stand closer in order to identify any significant changes in leakage. At the 15-foot mark, there was a minimal increase to 105 microamps. This indicates that the fog pattern is the safest method of delivery. The second test was a solid stream from the engine. The next process called for the delivery of F500 from the fire department engine using a 2-inch smoothbore tip. The test began at the 85-foot standoff distance, where we received current readings from 2 to 4 milliamps. This exceeded our 0.9 milliamp safety threshold. At that point, we began to back up from the conductors in 10-foot increments until the current leakage values dropped to the acceptable threshold. At 95 feet, the current dropped below the safety target of 0.9 milliamps. We have now established a safe standoff distance for this delivery process. In the third test, we used a large caliber stream from a tower ladder. Again, we began the test at the 85-foot mark using a multiversal nozzle, which delivers a large volume of water. In this case, 500 gallons per minute. This actually had no effect on the test process. We determined that the most conductive method of delivery was from the solid stream, so the apparatus, volume of water, or pressure had no influence on the current leakage values. Moving forward, we will be meeting with the fire departments that support the Con Edison service territory to discuss the test process and conclusions. This data clearly indicates the process to be safe and may ultimately change the way these fires are fought. Our goal is to ensure the integrity of the infrastructure, but more importantly, keep fire department members safe while operating in these high voltage environments. When you ask people to go against the grain of what they believe, you can't tell them that it's safe, you have to show them. Thanks for watching and stay safe.